The title of this presentation is The Use of Physics in Our Daily Lives by Charles Sturgill. Physics. Physics is more than just a subject that we learn in class. It's more than just math and science. It's more than just the equations that we use to solve problems in math or science. It is also part of our everyday lives. Physics affects everyone. So many of the things that we do, the things that we use, the games we play, the activities we do, all depend on physics in one way or another. Physics helps things to operate and to run smoothly. It also helps us to have fun and to come up with new ideas or findings in different things. For each of us to better understand physics, we need to understand how big of a role that it actually plays in our lives. Physics and automobiles. Most people own a car or use one on a daily basis. People have a variety of reasons for buying a car. Physics is a vital part of the automobile industry, and physics deals with the design and speed of the car as well as the safety features inside the car. So what I'm getting at with this slide is that everybody has different reasons for why they buy a car. Some is for safety, some is for speed, some is for economy. And because of those reasons, physics plays a part in a lot of those different reasons. Physics and automobiles continued. Safety is a major reason for people buying a specific car. A key safety component in cars are the seatbelts, and seatbelts are in place because of the law of inertia. To explain this, when a lot of people are thinking about buying a vehicle, one of the key things that they think about are the safety features, whether it be airbags, brakes, whatever. But the main one that I think of when I drive my car is seatbelts. Seatbelts are a huge component of the safety features in a car, and seatbelts go hand in hand with physics. Seatbelts are required to be worn. It's the law, and so in that case it's pretty good to have a solid set of seatbelts and to understand why they're part of the car. Physics and seatbelts go hand in hand because of Newton's first law. Newton's first law states that an object in motion continues in motion with the same speed and in the same direction unless acted upon by an unbalanced force. What that's saying is that most things tend to continue with what they're doing at a particular time, whether they are at rest or in motion. If there's not an unbalanced force, then the object generally stays in motion, which is referred to as the law of inertia. The law of inertia comes into play while you're driving or riding a vehicle. This comes into play because if a car is moving, then technically the person inside the car is moving. And if a car is at rest, then the person inside the car is also at rest. And this is where seatbelts come into play. Because when a car is moving, the person inside is accelerating along with the car. And the same goes for if the car is slowing down, the person also slows down. And if you get in an accident inside your car and you crash into a wall or other unbalanced force comes in contact with your car, then you're going to stop. And if a person is wearing a seatbelt, that person will stop along with the car, and they'll do whatever motion the car does after the crash. But if a person isn't wearing a seatbelt, then they're going to go outside of the car and possibly become harmed because of the accident. Physics and automobiles continued. Another reason for people buying a car is speed or performance. That drives a person's decision to buy a specific car sometimes, whether they be a speed enthusiast or a race car driver. Specific cars are designed for speed and performance, such as race cars or specific cars like Lamborghinis or something like that. So there's two factors that determine the speed of a car. And those two factors are horsepower and drag force. So when it comes to drag force, it is a constant issue for cars due to the fact that drag force increases by the square of the velocity. This means that the faster a car goes, the more forces are acting upon it. So when it comes to reducing drag force, it's all about the design of the car. When you come with the equation of drag force, there's not much that you can change because all that stuff is set. So when car designers are looking at reducing drag force, it's all about designing the physical look of the car. Because of the physical appearance of the car can affect the drag force and ultimately the speed of the car. Some of the things that designers use to reduce drag force is by generally lowering roof lines or making the bodies of the car more narrow. Physics and automobiles continued. Economy and efficiency are some of the big things that people want in cars, especially nowadays. They want the car to be eco-friendly, to be a little more green. But when you're thinking about the economy and the efficiency of the car, the size actually determines how eco-friendly that car can actually be. With this big push for going green and sometimes using alternative fuels, one of the best ways to do this is by changing your car, and in particular your engine size. The size of the engine plays a big part of how economically friendly your car will be. One of the ways to do this is by making the parts of the engine smaller or making them out of different or lighter metals and materials. So when you're thinking about the parts, you can think of them in physics terms where momentum is equal to mass times velocity. If the car parts weigh less, then the impulse force needed to change the momentum is lessened. This means that lighter parts equal less force, which means that there's less energy wasted and the car can be driven more efficiently. This same process can also be brought to the rest of the vehicle. If you make the actual car lighter, you can also make it more economic. So if you use the equation A equals F divided by M, you see that by reducing the weight of the car, a smaller amount of force will be needed to move the car, which will in turn increase the acceleration of the vehicle. In this slide, I just had a collage of different types of sports cars or race cars. The one in the bottom right corner is a car that's been more designed for aerodynamics to reduce less drag force. And then on the bottom left-hand side, there's an example of how drag force and stuff like that affects the car, which in turn depends on its speed. Physics and recreation. Physics plays a role in a lot of our recreational activities and a lot of the games we play. And since most everybody has hobbies or different games that they play, physics plays a huge part in that. Physics can be seen in a lot of games such as billiards or pool, baseball, tennis, stuff like that. And it can also be seen in more extreme sports for adrenaline junkies such as skydiving and rock climbing. Physics and recreation continued. Physics is a big part of the game of pool. In the game of pool, there's a lot of collisions. Collisions in physics are determined in physics, and they're a main part of the game of billiards. And there are multiple types of collisions that you can see while playing billiards, a couple of them being elastic collision and glancing collision. So the first that I'm going to talk about is an elastic collision. So when a billiard ball collides with another billiards ball, the collision is elastic. An elastic collision is one in which the kinetic energy of the system is conserved before and after impact. Another type of collision that can be seen while playing the game of billiards is a glancing collision. And that is when one object in motion collides with another object that is at rest. After the collision, one of the objects goes off at angle 1 with respect to the horizontal, and the other object goes off at a different angle with respect to the horizontal. This is seen through the majority of your time playing billiards, especially, for example, when you're lining up your cue ball and you're going to hit that 8 ball. It's the last ball you got it lined up for a specific corner pocket. The 8 ball's at rest. When you line it up, you hit the cue ball and it glances off the 8 ball when the 8 ball goes off at an angle towards the pocket that you want it to go towards, and the cue ball goes off at a different angle. And that's a general idea of glancing collisions and how it goes in billiards. Physics and recreation continued. Physics can also be seen in other sports that are a little more extreme and not as safe as just billiards or baseball and stuff like that. The one I'm going to talk about is skydiving. Skydiving is all about jumping out of a plane and free falling for a certain amount of time. During the free fall, the skydiver is met with air resistance during the duration of the jump. Air resistance depended on two variables: speed of the skydiver and the cross-sectional area of the skydiver. So when a skydiver jumps out of the plane, the first thing they feel is the air resistance as they fall towards the ground. The amount of air resistance will differ depending on the two variables that I said, the first being the speed of the skydiver and the cross-sectional area of the diver. When we're talking about the speed of the skydiver, they accelerate as they fall, and that speed increases and because of the speed increases, the amount of air resistance also increases. Then, in this situation, the force of gravity is countered by the force of air resistance. And as the skydiver falls faster and faster, the air resistance becomes greater and greater until it reaches the magnitude of the force of gravity. Once the force of air resistance is as big as the force of gravity, a balance of forces is attained and the skydiver no longer accelerates. At this point, the skydiver reaches a point called terminal velocity. At this point, the skydiver no longer accelerates, but they remain at a constant speed. The second factor that comes into play is cross-sectional area of the skydiver. This means that a skydiver that is like spread eagle as they're falling has a larger cross-sectional area than one that's in a ball and just free falling. The cross-sectional area comes into play generally when the parachute is ready to be released. When the parachute opens, the net force and acceleration of the diver goes upward, which causes the skydiver to slow down. The skydiver will again reach terminal velocity at this point, at a certain point where they will stop, they will decelerate and fall at a consistent rate to the rest of the time until they come stop at the ground. Here's another collage of what I was just talking about. We've got the skydiver who's free falling, got a larger cross-sectional area right there, a little bit spread eagle. And then at the bottom right corner, we have one where their parachute's open, and you can see they're decelerating, large cross-sectional area with the parachute open. Then at the top, we also have the picture of a game of billiards that I was talking about, where there's fixing to be a collision. And then at the bottom, there's a baseball player, which physics also plays a role in. And that's the end of my presentation. Thank you.